Okay, video number 2, hopefully meant to clarify what questions 2 and questions 3 are asking. They're really just about transformations and how to modify one graph to look like another graph. So here's basically what it should say. So we want to describe the transformations needed to map f of x equals 1 over x to g of x equals negative 3 over x minus 5 plus 2. So basically the big things are how do we turn f of x into this function, g of x? They're graphs. So f of x, you hopefully remember, looks like this. And really, what it's getting at is what are all these numbers doing and changing f of x to make it g of x. So let's start with this big old negative sign in front. That negative flips f of x over the x-axis. That's what that does as a transformation. So first thing, we've got a flip over the x-axis. Other things going on here. You've got this big old 3 sitting in front on the top. That 3 is a VS Bafo 3, or a vertical stretch by a factor of 3. It's just going to make it steeper because that's a 3. What else we got? We've got this plus 2 on the end. That plus 2 basically moves us up 2. And those are all the vertical things that are different than the function. The one thing you hopefully noticed that we have not covered yet, or talked about yet, is this minus 5. So that minus 5 sends us to the right 5. Hopefully you remember the big catchphrases on our transformation rules. Inside stuff is horizontal and backwards. That's why minus 5 sends us to the right 5, not to the left 5. Outside stuff is vertical and normal. So 3 makes us bigger. This is a vertical stretch by a factor of 3. Please feel free to write VS Bafo if you want. That's fine. But the real words are vertical stretch by a factor of. Plus 2 moves us up 2. That's normal. That's on the outside. Minus flips us over. If you kind of paid attention to the even-odd video, odd functions are functions where an x-axis reflection and a y-axis reflection actually do the exact same thing. So this negative, technically it is an x-axis reflection, but if you were making the graph yourself, if you accidentally flipped it over the y-axis, you'd actually get the exact same graph. Because 1 over x is a quirky function, aka an odd function. But that's it. All it wants to know is what transformations need to be done to 1 over x to make it this new graph, aka what are all these new numbers doing to the standard parent function 1 over x. So let's look at another one that sort of is similar to number 3. So number 3, we can just do a function like g of x is equal to 2x plus 9 over x plus 3. I don't care. Something like that. So x plus 3 goes into 2x plus 9. This is kind of annoying that it looks like this because you can't actually see those transformation rules. So this is the one where you want to kind of divide first. So you put a 2 up here. 2 times x is 2x. 2 times 3 is 6. It's maybe been a little while since you've done some long division, but remember you're subtracting all of these terms. So it should be 2x minus 2x, that's nothing. 9 minus 6, that's 3. And then the deal is plus 3 over x plus 3. So g of x is now 3 over x plus 3 plus 2. You maybe like it better with that 2 on the end. Instead of saying 2 plus, you can say plus 2. Just keep the signs the same and you should be okay. And now it's sort of in the standard template for noticing transformation rules. So what I would say about this function is this one has a VS BAFO 3. It's been vertically stretched by a factor of 3. This plus 2 moves it up 2. And then the only horizontal transformation involved is this plus 3. The plus 3 sends us left 3, which is kind of backwards. Outside stuff is vertical and normal. Inside stuff is horizontal and backwards. So this is going to change where all the asymptotes are. Not what this question is asking you to do. It doesn't care where the asymptotes are, just how is the graph different. Now you're going to care about the asymptotes if you want to make the graphs, which you're going to on some of the subsequent problems. But that's about it in terms of what question 2 and 3 are getting at. Just what transformations need to happen to f to make it g. Those functions are backwards on your paper. It should have been f first and then g. I just put them in the wrong order. Sorry about that. But f should have been the first function. F's the parent function. F's the function we're moving to make the new function g, which is just a slight modification of f. So that's it.